Assalamualaikum warahmatullahi wabarakatuh. My name is Syakilla Binti Azni with matric number AN190031. My supervisor is Associate Professor T.S. Dr. Nur Akmazila Binti Muhammad Fazil. Today, I would like to present my final year project entitled Anti-Inflammatory Study on the Extraction of Odorata and Azadirachta indica leaf by using traditional cold maceration and high pressure processing method. The first part I will present is abstract. Over the years, studies on the anti-inflammatory activity of plant extract has gained popularity. Anti-inflammatory is known due to its ability to prevent or reduce inflammation in the body. However, the extraction method plays a crucial role in exhibiting the anti-inflammatory properties presented in medicinal plants. In this study, different extraction methods were applied on the Chromolaena odorata and Azadirachta indica plant. Traditional cold maceration and high pressure processing method with different extraction conditions was used. The samples were analyzed on this anti-inflammatory activity by using protein denaturation assay technique. The results showed that cold macerated C. odorata and A. indica extract exhibit the highest anti-inflammatory activity of 72 hours of maceration. Meanwhile, for traditional method, both extracted plants show the highest anti-inflammatory activity at 30 minutes extraction. During HPP extraction, the highest anti-inflammatory activity of C. odorata and A. indica were recorded at pressure of 200 MPa for 15 minutes and 10 minutes respectively. However, the result obtained did not show a significant difference between all extraction methods. Hence, it can be concluded that the anti-inflammatory activity of C. odorata and A. indica were not significantly affected by traditional cold maceration and high pressure processing method. However, HPP extracted samples show the highest anti-inflammatory activity. This finding is useful particularly in the food, cosmeceutical, health-based product industry since Chromolaena odorata and Azadirachta indica might be act as a natural anti-inflammatory substance and potential healing agent that can reduce harm to human health. Next, I will explain about the study problem, statement and objective. Firstly, in Malaysia, both plants are planted and located in relative abundance. However, local people are still clueless and lack of knowledge about the anti-inflammatory properties contained in both plants. Moreover, the research of both plants on the anti-inflammatory potential in one health individuals is still very limited. Lastly, in production, the extraction of plant is a crucial step since bioactive compound is easily degraded. However, the study on comparison of anti-inflammatory activities between types of extraction methods are still limited. In literature review, 6 subtopics will be covered. Firstly, Chromolaena odorata. Chromolaena odorata is originated from Central and South America but widely distributed across tropical and subtropical areas. It belongs to Azadirachta family. It also contains components such as tannin and alkaloid. Next, Azadirachta indica. Azadirachta indica is a plant that originated from Indian subcontinent but mostly grown in Asia and Africa southern areas. It belongs to Meliaca family. It contains complicated constituents including limbin, nibidin, nimbolite, and also levanoids. The next part is the extraction method. The first one is traditional extraction. Traditional extraction is a method involving dissolving the powder of the leaf sample with distilled water and boil it at certain temperature for a certain time. Meanwhile, cold maceration is a solid liquid separation operation where objects in solid phase will be placed in contact with the solvent. It comprises soaking a plant in a solvent such as water, oil, or alcohol for a variable amount of time while shaking occasionally, depending on the plant material and liquid employed inside an airtight container. High pressure processing (HPP) is a non-thermal method that carries out a very high pressure range from 100 MPa to 600 MPa at ambient temperature. Next, protein denaturation. Protein denaturation is a biochemical process that involves the disruption of covalent bond in protein structure. It is used to determine anti-inflammatory activity as because the potential for a sample to inhibit protein denaturation may prevent the inflammatory illness. Thus, it is used as SNAC that determine the anti-inflammatory activity of samples. Now we move to anti-inflammatory properties of Chromolaena, odorata, and Azadirachta indica. There are a lot of compounds that in charge in active inflammatory properties. For both Chromolaena, odorata, and Azadirachta indica, both of them contain quercetin. Quercetin is described as a long-acting anti-inflammatory with strong anti-inflammatory properties. And lastly, herbs as one healing agent. Various compositions in herbs help to expedite one healing and useful in one treatment. Antioxidant, antiviral, antimicrobial, antifungal, and also anti-inflammatory in herbs are related to the one healing process. In this part, I will explain about the methods used to achieve the objective of the study. Firstly, both Chromolaena odorata and Azadirachta indica leaf sample were collected at Nasuha Herbs and Spice Farm. The collected sample then were cleaned with clean water and dried for 2 days in oven at 50 degrees Celsius. Next, the dried leaf were grinded into powder form. The powder form of leaf sample then will undergo extraction by using different extraction methods and different conditions as shown. The anti-inflammatory of the samples were evaluated by using protein denaturation assay. Lastly, percentage inhibition of protein denaturation by the samples were calculated to determine the anti-inflammatory activity of the samples. Now, I will discuss about the result obtained from the study. Table 1 showed the anti-inflammatory activity of Chromolaena odorata and Azadirachta indica extract by using traditional extraction method at different extraction time. Based on the result obtained, the anti-inflammatory activity for both extracts show an increment with increased concentration and the extraction time. The highest anti-inflammatory activity of both plant extracts were recorded at 45 minutes of extraction. Extraction time seems to give a positive effect on anti-inflammatory activity of both leaf extracts as depicted by the increment of anti-inflammatory activity along with increment of time. However, the anti-inflammatory activity of Azadirachta indica extract with 30-minute extraction at concentration of 1000 microgram per ml show decrement value from 500 microgram per ml. This observation is contrary to result obtained by Cartoon in 2001, which stated the inhibition of protein denaturation is increased when the concentration of sample increased. The degradation of flavonoid during the protein denaturation assay might contribute to the reduction of anti-inflammatory activity. Even though the highest anti-inflammatory activity of both leaf extract is at 45 minutes, no significant difference was found for 30 minutes of extraction. It can be concluded that from the study, extraction time do not have significant effect on anti-inflammatory activity for both extracts. Hence, it can be deduced that the best extraction time for both samples are 30 minutes. Next, for Table 2, it shows the anti-inflammatory activity of both plants by using cold maceration method at different extraction time. The highest anti-inflammatory activity of macerated Chromolaena odorata extract were found at 72 hours. This might indicate that the maximum amount of bioactive compound in Chromolaena odorata extract were presented during 72 hours of maceration. Meanwhile, the anti-inflammatory activity of Azadirachta indica leaf extract shows a major decrement when the concentration was increased from 500 microgram per ml to 1000 microgram per ml for 96 hours. At 72 hours and 48 hours of extraction process, the inhibition of protein denaturation shows a fluctuate trend, but the inhibition of protein denaturation was found to be increased again at the concentration of 1000 microgram per ml. It was also observed that the longer extraction time, the higher is yield of extract produced. As the time increases, more solvent will be permeated through the cell wall and solubilize the plant's constituent. However, the anti-inflammatory activity for both plants in this research act the best at 72 hours of maceration and followed by 96 hours. Moreover, the results obtained also do not have significant difference. Based on the observation at the highest concentration of 96-hour extraction time, the activity of Chromolaena odorata extract is proximate with 72 hours extract. It specified that the amount of phytoconstituent that involved as anti-inflammatory agent might be in the same amount. Thus, from this study, it can be deduced that 72 hours is the best condition for co-maceration method for both plants. The next table that will be discussed is the table of anti-inflammatory activity of Chromolaena odorata and Azadirachta indica extract by using high-pressure processing HPP method at different pressure and different extraction time. Based on the result, the highest anti-inflammatory activity for both plants leaf. The next table that will be discussed is the table of anti-inflammatory activity of Chromolaena odorata and Azadirachta indica extract by using high-pressure processing HPP method at different pressure and different extraction time. Based on the result, the highest anti-inflammatory activity for both Chromolaena odorata and Azadirachta indica leaf extract were recorded at pressure of 200 MPa at 15 and 10 minutes. Previous studies stated that the highest pressure used, the highest extra yield will be obtained. However, from this study, the anti-inflammatory activity for both plants were held at 200 MPa, which different from the previous research. From the observation, the activity of both Chromolaena odorata and Azadirachta indica leaf extract at 600 MPa were slightly lower than 200 MPa might be caused from the loss of bioactive compound during performing the analysis work. Bioactive compound is very sensitive to light as it will cause ultraviolet radiation. During the analysis work, using an assay, some light might be penetrate the leaf extract and cause the chemical transformation. The last table describes about the anti-inflammatory activity of salicylic acid and extracted sample defined from the best extraction condition. Salicylic acid is used as positive control. From the data obtained, the leaf extract of Chromolaena odorata using cold maceration method has the most closest anti-inflammatory activity with salicylic acid. Salicylic acid reduces the generation of pro-inflammatory mediators, but taking it in a large dose could affect health. Thus, with the presence of natural anti-inflammatory agents that have almost same anti-inflammatory activity with salicylic acid, the risk of using harmful substance could be reduced. However, cold maceration method is a method that involves chemical and takes a longer time to completely obtain the extract. Thus, in order to reduce the time and avoiding the use of harmful chemicals, HPP method is highly recommended. The result from this study shows that HPP can perform in shorter time and give higher value of anti-inflammatory activity. Conclusions. This study has successfully demonstrated the anti-inflammatory activity of Chromolaena odorata and Azadirachta indica leaf extract. The anti-inflammatory activity of Chromolaena odorata is slightly higher than Azadirachta indica. The highest anti-inflammatory activity of both plants were obtained at 72 hours of maceration. From the result obtained, HPP at 200 MPa can be applied instead of cold maceration because it can help to reduce the loss of bioactive compound in the extract. From this research work, HPP extracted sample give a higher value of anti-inflammatory activity of Chromolaena odorata and Azadirachta indica as compared with traditional and cold maceration. That's all from me. Thank you.